Hello dear students, welcome back to the chemistry class. In the previous class we are discussing about the preparations of alcohols and phenols, right? So in last class just we have started the preparations of alcohols, and in that we have completed about the preparations of alcohols from haloalkanes. So this part already we have completed the preparations of alcohols from haloalkanes. This is already we have finished. That is when this haloalkanes Rx, when it is treated with, and this is treated with a base like sodium hydroxide or potassium hydroxide or silver hydroxide, that is moist silver oxide. So in this case we will get the product ROH. So these reactions already we have completed. Next one, the second reactions we have started about, that is the reduction of carbonyl compounds. We have just started this one, right? Reduction of carbonyl compounds we have started. So let's continue with the preparations of alcohols from haloalkanes. This is completed. The next one is a reduction of carbonyl compound. In that, reduction of aldehydes and ketones. I think this is also we have finished. A reduction of aldehydes and ketones also we have covered in the last class. That is when a aldehyde, any aldehyde or ketone, aldehyde means the last is it is H, ketones, that is R C double bond O R dash. When any aldehydes are ketones, when this undergoing a reduction, that means in the presence of a reducing agent or a reducing agent, that is the process is reduction in the presence of reducing agent. So particularly which reducing agents we have used? So we have used the reducing agent. The main strong reducing agents are lithium aluminum hydride, sodium borohydride, etc. But along with that, hydrogen in the presence of nickel palladium platinum we can use, or even sodium in ethanol, that is in the basic medium which produce the nascent hydrogen and that utilize for the reduction of aldehydes and ketones. So in this reactions what we have studied, that is the CO group, the carbonyl group is converted into RCHOH, CHOH. So here also same, the ketone, the carbonyl group of the ketone is also, this group is also converted into CH single bond OH. So here this is a primary alcohol and this is a secondary alcohol. So these two reactions we have completed in the previous class, right? Okay, so let's continue with the next one, the reduction of carbonyl compound. In that, reduction of aldehydes or ketones. When an aldehyde or ketone undergoing a reduction in the presence of a reducing agent, that gives rise to corresponding alcohols. That is, aldehyde gives rise to primary alcohol, whereas the ketone gives rise to secondary alcohol. Now let us move to the next one, that is a reduction of carboxylic acid and esters. Carboxylic acid, the functional group RCOOH, carboxylic acid. When this carboxylic acid undergoing reduction, this gives rise to, when it undergoing a reduction, it gives rise to the product. See here. So carboxylic acid, when R C double bond OOH, when carboxylic acid undergoing reduction in the presence of lithium aluminum hydride, this gives rise to a product of RCH2OH, RCH2OH. Look at this, the carboxylic acid group COOH group is converted into CH2OH. CH2OH. And remember this reaction, the reduction of carboxylic acid by using lithium aluminum hydride, it gives a best yield of alcohols. But these reactions we cannot be used in the laboratory. We cannot use because of the very expensive of lithium aluminum hydride. This is very expensive in nature. So for that reason, we are using an alternative method for the reduction of carboxylic acid into alcohol. So instead of that, okay, we can use other reducing agents like, so sodium in the presence of ethanol, sodium in ethanol, it also gives rise to alcohols, but this gives a very high yield of alcohols from carboxylic acid. And particularly lithium aluminum hydride, this reducing agent is used only to prepare some specific compound, organic compounds, because of it is very expensive. So the alternative method, how we can prepare alcohol from carboxylic acid. So first, these carboxylic acid, first it is converted into esters. Look at this. So when this carboxylic acid RCOOH, when it is treated with an alcohol, carboxylic acid, so this is converted into this in the presence of an alcohol ROH. This gives rise to RCOOR dash. Let us take this as a R dash. And when this undergoing reduction in the presence of sodium in ethanol ETOH, this gives rise to a product alcohol. So here, so one is from this part, from carboxylic acid part, and other one is from this. So it gives rise to a product R, and one more is CH2OH, RCH2OH, plus the other one is R dash OH. R dash OH. This is an alternative method we can use to get the alcohol from carbonyl compound. First one from carboxylic acid, and even from ester we can produce the alcohol. Is it clear? Okay, right. The next one, the next is by the hydrolysis of esters. Yes, as already we have studied the reduction of ester. Hydrolysis of ester, when this ester, when it undergoing hydrolysis of ester R COOR dash R dash, when this undergoing hydrolysis means addition of water, so it gives rise to here H, and this side is OH, water is added. So this part gives rise to carboxylic acid RCOOH, and this further undergoing reduction to give RCH2OH. Whereas from this side, this is also alcohol. So alcohols we can get from esters. So here these are the carbonyl groups, carbonyl compounds. So that is, one is aldehyde R C double bond O H aldehyde, ketones C double bond O R, carboxylic acid OH, ester COOR. So in all these cases, the product by the reduction of these carbonyl compound, it gives rise to the product alcohol ROH, that is from carbonyl group. The next important reaction is from Grignard reagent. From Grignard reagent, this is a very important reactions to prepare the alcohol. See, in this case, we are getting the different alcohols, that is primary alcohol, secondary alcohol, and tertiary alcohols also we can prepare by using the Grignard reagent. What is the formula of Grignard reagent? Grignard reagent RMgX, alkyl magnesium halide, Grignard reagent, right? So when this Grignard reagent is treated with aldehydes, ketones, esters, and oxirane. So in these four reactions we are going to study under the heading of Grignard reagent. Under the heading of Grignard reagent, see that first one. So here, when the Grignard reagent RMGX is treated with, it is treated with number one, aldehyde. When it is treated with aldehyde, particularly formaldehyde, HCOH, other than formaldehyde, any other aldehyde also we can choose, or when it is treated with ketone, or when it is treated with an ester or COOR, or when the Grignard reagent is treated with oxirane, that is ethylene oxide, CH2CH2O, like epoxide. So oxirane. So in all these cases, when a Grignard reagent is treated with this compound, it produces, the product is alcohol. Let us study one by one. So how it gives rise to alcohol. Remember, whenever we are using the Grignard reagent with these carbonyl groups, the mechanism part is same. The mechanism part is same. Look at this. Let's study one by one. So from this Grignard reagent, first one with aldehyde. So when the Grignard reagent is treated, a Grignard reagent RMGX, first one, first one, reaction of a Grignard reagent with, reaction of a Grignard reagent with formaldehyde, with formaldehyde, HCHO, with the formaldehyde, HCHO. So HCHO or MgX, when this Grignard reagent is treated with, when it is treated with a formaldehyde, HCHO, what happens? See, the mechanism is same in all the case. In Grignard reagent, halogen is electronegative element, whereas the magnesium is electropositive, and this is R group is an alkyl group. So when compared to this bond is, it is ionic because magnesium is partially positive, whereas this R group is partially negative. So it is Mg2 plus. So here this will be a partially negative group. And as we know that this carbonyl group is electron deficient center because of more electronegative nature of oxygen. So this carbon will get an partial positive charge. The bond is polar. The carbonyl group is the reactive part. So where the carbon is electron deficient, so what happens here? This R group will attack to the electron deficient center, that is carbon. So when the R group attack on this carbon atom, so one of this bond is get shifted on its oxygen. So as a result, it gives rise to an intermediate. Look at that intermediate, the R group. This is the R group which comes from Grignard reagent, and this is attack with this carbon atom C. So this carbon atom is linked with 2 hydrogen. I am writing as it is 2 hydrogen. So these are the hydrogen attached to the carbon, and one bond is get shifted, so it becomes single bond, and this is the oxygen, and on oxygen it getting a minus charge, right? So this is the displacement of electron takes place. And when this R part is attacked to this carbonyl group, the remaining part of this Grignard reagent, so this will be a positive part and it attack to this negative charge. So this is Mgx along with this plus Mgx, OMgx. That is the remaining part of Grignard reagent. So to this compound, an intermediate compound, when this undergoing hydrolysis, when it undergoing hydrolysis, HOH, the water is added undergoing hydrolysis, it gives rise to the product R CH2, R CH2, and this one is OH plus. Remember, whenever we are using the Grignard reagent, the byproduct will be preferably it is magnesium hydroxide halide, MgOHX. MgOHX. This is the byproduct with Grignard reagent, right? So when the Grignard reagent is treated with particularly formaldehyde, so when it is treated with a formaldehyde, it gives rise to 1 degree alcohol, that is primary alcohols are produced. Primary alcohols. Please note that when Grignard reagent is treated with particularly formaldehyde, not other aldehyde, I am taken formaldehyde. I have taken this formaldehyde. So formaldehyde gives rise to primary alcohol. Is it clear? Okay. The first reaction is clear. That is Grignard reagent when it is treated with formaldehyde, that gives rise to primary alcohol. You can take some examples. So with formaldehyde, or simply just I am asking how you are going to prepare, CH3 CH2 CH2OH, CH3 CH2 CH2OH from carbonyl compound. So identify the product A and B. So here A and B you need to identify. So the product we should get this alcohol, propanol. This is one homework for you. So identify A and B. Second one, same, identify A and B in the followings. A plus B, it gives rise to benzene ring, CH2OH, that is benzyl alcohol. To get this, what are the reactant required? Identify A and B in the following reaction. Identify A and B, A plus B, A plus B. So here in these two reactions, let us identify the product A and B. So by taking these two A and B, we want to prepare, one is propanol and second one is benzyl alcohol. This is some examples I have given. Indirectly I have given some example. You need to work out on these two examples, right? Next example, next one. Next, so the first reaction, that is Grignard reagent with formaldehyde I have taken to prepare the primary alcohol. Next, preparation of secondary alcohol. So how we can produce the secondary alcohol with the Grignard reagent? Let's see. Second one. So when this Grignard reagent is treated with, second one, reaction with aldehydes other than except formaldehyde, means other than aldehyde, other than formaldehyde, you can use any aldehyde, you will get the secondary alcohol. So look at this how. So when a Grignard reagent RMGX, when it is treated with Grignard reagent, when it is treated with alcohol R dash C double bond OH, this is an aldehyde. As earlier I said that the mechanism part is similar. So here from the Grignard reagent, this R part will be an partially negative, electron rich, because this magnesium is electropositive, more electropositive, and this carbon is electron deficient because of polarity of this bond. Oxygen is more electronegative, the electrons are attracted towards oxygen. This carbon will be an electron deficient. As a result, so this R part, the alkyl group, will attack to this electron deficient center immediately. So this bond will be get shifted on oxygen. Simultaneously, the remaining part of the magnesium will attach with this oxygen itself. So in the last case, I have shown in the second step. So directly I have total three part. Alkyl group attached to this carbonyl carbon. This bond will get shifted and the remaining part will attack to this. So look at this. What happens here? This is the R group. R group. R group is attached with the carbon. This is the carbon. So this carbon containing two. One is hydrogen and other one is R dash. So where the R comes from Grignard reagent and R dash from aldehyde. So one bond will get shifted on oxygen, it getting minus charge. The remaining part is magnesium halide. So this is an intermediate. When this undergoing hydrolysis, it gives rise to H and OH. So this gives the product R CH R CH R dash OH. So this is an 2-degree alcohol, that is secondary alcohol, plus as product is magnesium hydroxide halide, MgOHX will be the byproduct. Is it clear? So here this R groups comes from Grignard reagent. This is from RMgX. So which Grignard reagent you have taken? And this R dash is from aldehyde group. This is from aldehyde group, CHO. This is from aldehyde group. So this is a secondary alcohol. Secondary alcohol. Now you can write some of the example for this also to get secondary alcohol. So some of the examples. Look at these examples. So when an acetaldehyde, simple example, when acetaldehyde CH3COH, when this acetaldehyde is treated with, when it is treated with methyl magnesium, methyl MER, simply we can write CH3 CH3 MgBr, CH3 MgBr. So followed by, when this in the presence of, instead of writing this plus charge, we'll write reagent part. So when this aldehyde, when it is treated with Grignard reagent followed by hydrolysis H plus, followed by hydrolysis H plus, or you can write H3O plus. So in the first step, the Grignard reagent, the carbon alkyl group attack to this, the remaining part will changes to the oxygen, and in the second part, hydrolysis takes place, which gives rise to the product. So here intermediate part is we are not required, so directly write the product, which product we are getting. If you want, you can write directly or follow the mechanism as it is. So what will be the product in this case? So product, how to find the product? So one group is CS3. So this is the alkyl group. So this alkyl group is attacking on this carbonyl carbon, and the remaining part of Grignard reagent, because one bond is get shifted on this, it getting minus charge, and this will attack to this. So what happens in the first step? First step, this is the CS3 part from aldehyde group, CS3 C, and this is H as it is, and it becomes O single bond O minus. Initially it is double bond, one bond is get shifted and it become minus, and this magnesium MgBr, magnesium halide. So this is from Grignard reagent attack to this. So when one CS3 group is attacking to this carbon atom, that is a CS3, this is from Grignard reagent. And when this undergoing hydrolysis, addition of water, it gives one H and other one is OH group. So what is the product? One is CS3. This CS3 from aldehyde group CH, CS3 CH, and to this one more CS3 is added, and this comes from Grignard reagent, and this is the OH group. This is OH, that is alcohol. So CH3 CHOH CH3, this is a secondary alcohol, 2-degree alcohol we are getting. Secondary alcohol, right? Is it clear? Okay. If it is clear, then solve one problem. Very simple problem I will give. So here again, identify A and B in the followings. A plus B, this gives rise to A plus B, it gives rise to, which gives rise to the product benzene ring CHOH CH3, CHOH, CH3, a simple compound I have given. So this is the product, secondary alcohol. To get this product, so what are the reactant you have used? One will be an aldehyde and other one will be Grignard reagent. Select the aldehyde and Grignard reagent. That is, identify A and B in the following reaction. So similarly, similar to this, when A plus B, which gives rise to, second example, CH3 CHCH3 CHOH CHOH C2H5 C2H5. So this is the secondary alcohol, CHOH secondary alcohol. To get this secondary alcohol, what are the reactant we are used? Identify A and B in the given reaction. This is the second one, right? Now the third one to get tertiary alcohol. To get tertiary alcohol. So Grignard reagent, when it is treated with aldehyde, we are getting primary and secondary alcohols. When Grignard reagent is treated with ketone, it gives rise to the tertiary alcohol. Look at this. When n ketones, I am taking ketones, C double bond O R dash. R and R dash. Just one ketone I have considered. R dash. This is the groups present in the ketone. When this is treated with R double dash, that is from Grignard reagent part, MgX. MgX. So shall I write directly? So within the step, directly, if you understood the mechanisms of this Grignard reagent, you can write directly, no problem. So this R double dash, that is from Grignard reagent part, this attack to this electron deficient carbon, carbonyl carbon. So immediately one bond will get shifted on this. So what will be the product? So this product R from ketone, single bond, one oxygen, this is R dash, right? So one R double dash will attack to this atom and oxygen is get shifted and to this oxygen MgX, MgX, that is from Grignard reagent, MgX. So this is the first step. In the second step, hydrolysis. Hydrolysis means addition of water. So upon hydrolysis, this gives rise to, what is the product? Look at this product. So this is R C R dash and this is R double dash OH. Now it becomes OH. So this carbon is a tertiary carbon atom, right? So this is tertiary alcohol. Tertiary alcohol plus byproduct MgOHX. It is common. Mg, magnesium hydroxide halide, is the byproduct. So tertiary alcohols we are produced. Tertiary alcohol. Is it clear? Yes, just recall this one. Next, tertiary alcohols. Tertiary alcohol, right? So when a Grignard reagent is treated with, when a Grignard reagent is treated with RMgX, RMgX, when a Grignard reagent, when it is treated with formaldehyde HCOH, when it is treated with formaldehyde HH, when it is treated with formaldehyde, the R group will attack to this carbonyl group. So this R alkyl group from the Grignard reagent, it is attacked to carbon of this and it is to hydrogen. One bond is get shifted and upon hydrolysis it gives rise to alcohol, that is primary alcohol. So first step, when it is treated, Grignard reagent is treated with formaldehyde followed by hydrolysis, we are getting a primary alcohol, 1 degree alcohol. Second one, when this is treated with an other than formaldehyde, any aldehyde, again I have taken the aldehyde, but one hydrogen, one group is R group, other than formaldehyde I have taken. So let us consider this as R dash. It is R. So this R will attack to the same carbonyl compound. It gives rise to R. This attack to carbonyl compound and this R dash remains as it is. And this is one hydrogen. This hydrogen, that is I am writing just as it is, CH, single bond O, and after hydrolysis it gives rise to alcohol. So this is secondary 2 degree alcohol. Secondary alcohols are the product in this case, secondary alcohol. When the same Grignard reagent is treated with, ketone, that is ketone R, R dash, R double dash. You can take any R, R dash, R double, or simply just mention the R. So just to differentiate between the alkyl group of Grignard reagent and aldehydes and ketone, just I have mentioned R dash, R double dash, etc. So in this case, the R group again attack, this R group attack to the carbonyl carbon, so which containing two alkyl group, which contain two alkyl group, and one double bond gets shifted on oxygen, to which the remaining part of the Grignard reagent but which attacks, and after hydrolysis it gives rise to OH group. So this is tertiary alcohol. Tertiary alcohol is the product. And along with these primary, secondary and tertiary, the one more byproduct is common, that is magnesium hydroxide halide. MgOHX is common byproduct with these, right? So this is about the preparation of primary alcohol, secondary alcohol and tertiary alcohol with formaldehyde. Second one is acetaldehyde or other than formaldehyde and ketone. Along with this, two more reactions we need to study. That is Grignard reagent reaction of Grignard reagent with ester. Let us continue here only. When the Grignard reagent is treated with ester or COOR, what happens here? Can you predict what happens in this case? So let us see this one mechanism. And second one is oxirane, that is CH2OCH2. So in this case, what will be the product? So before filling these two, if you want, you can write down the product. Pause the video and predict the product, write the answer and then verify. Okay, now I will give explanation to these two. Let's check first. With ester, when alkyl magnesium halide, that is from Grignard reagent, when this alkyl group, when it attacks to the ester or COOR, so this R group, when it attacks to this carbon, similar, same mechanisms will be same. The one bond will get shifted on this oxygen, the other part will attack on this, so which gives rise to R, C, O minus, O minus, and this is an alkyl group, this is OR, OR. So in the first step, so before attacking this, so it reminds, let it take later. So in the first step, so as we know that this bond is also polar, when the double bond is gets back, when it comes back, this OR bond will eliminate, which gives rise to the product RCO R dash, RCO R dash, R dash. So here this OR part minus OR, alkoxy group will be eliminated first and it gives rise to ketone. When ketones are come, so in the presence of excess of that Grignard reagent, you can predict the product. So it is a tertiary alcohol, OH, R and R, tertiary alcohols you can get. Hope it is clear. Look at this, how we can represent this reaction. So first an ester I have taken, RCOOR. This in the presence of a Grignard reagent, RMgX. First this converted into ketones, because when this R group will attack on this, the minus charge will comes on oxygen. When it comes back, this OH group will be eliminated. So here, so R group is added, OR group is eliminated. So this gives rise to RCOR. It becomes ketone. And this in the presence of RMgX. So ketone and Grignard reagent, already we know that it gives rise to the product tertiary alcohol, 3-degree alcohol. So tertiary alcohol are produced in this case. What about with oxirane? with oxirane. Remember, this reaction is also an important reaction which is used in order to increase the number of carbon atom as compared with the reactant. We can use this oxirane. So RMgX, Grignard reagent, when it is treated with oxirane, that is ethylene oxide. So this R group, first it will attack on one of the carbon atom which is more electron deficient. So here both are equally deficient. Now when it is attack on this carbon atom, so this bond will be polar because of oxygen is more electronegative. As a result, this bond will get shifted on the oxygen. So what happens? So this is the R group, it gives rise to first this R group, and this R group attacking on this carbon atom, that is a CH2, it is linked with another CH2 group, and then this is one oxygen minus. The remaining part of the Grignard reagent will attack to this, and then upon hydrolysis this gives rise to the product R CH2 CH2OH. CH2OH. Look at this. So in the reactant side, so in order to increase the number of carbon atom, 2 carbon atoms are more, and which comes from oxirane part. 2 carbon atoms are increased in this case. So this is the and another example, if you want to select, if I have taken a different epoxide, that is CH3 CH CH2 oxygen plus Grignard reagent CH3 MgX. Identify the product. So here the major doubt is the CH3 group, the alkyl group of the Grignard reagent, whether it attack to the carbon number 1 or carbon number 2. Because now in this case these 2 carbon atoms are not equally electron deficient, so there will be something difference. So here what happens, so this carbon is less electron deficient, because so oxygen is more electronegative, which attracting the electron from these two, but here one CH3 group, this alkyl group, is an electron releasing group. So therefore, because of the plus I effect, this carbon will be more electron deficient. As a result, so this alkyl group attack on this carbon atom, and this bond will get shifted on the oxygen. So it gives rise to the product. This is CH3 single bond CH. So this bond is broken. Now it is O minus. This is O minus, and this is CH2, and another one is CH3. Now, so remaining part, it is continuation same, magnesium halide. Upon hydrolysis, this gives rise to, after hydrolysis, which gives CH3. Upon hydrolysis, this gives rise to CH3, CHOH, and CH2CH3. CH2CH3. Please note these reactions. So these are the reactions of Grignard reagent with the carbonyl compounds. So preparations of alcohols from carbonyl compounds. Right. The next one is preparations of alcohols from alkenes, and important reactions. So this from second alkenes will continue in the next class. Okay. Thank you. So in the next class, we'll continue with the preparations of alcohol from alkenes. We'll continue in next class.